Hello out there, welcome to this tutorial on quadratic equations. So in this video we'll be looking at factorization method of solving quadratic equations. So we start with the first problem. Problem 1, solve these quadratic equations. We have equations from A, B, C and D. We are going to start from the first equations. We have x squared plus 3x plus 2 equals 0. This is the standard form of quadratic equations, where we have the first term to be of degree 2 and the second term is the term with x with degree 1 and the third term is the constant term. So here, since the coefficient of x squared is 1, so our concern shall be on 2. So we'll be looking for two factors of 2 whose sum will give us the coefficient of x. So before we go, we split this x squared into 2, so that we now have it as x in bracket, x in the second bracket. So we now go ahead to look for two factors of 2, and in looking for two factors of any numbers, so what we do is we consider the number itself and 1. Do they give us the sum we are looking for? And here, if you consider 2 and 1, the sum is positive 2 plus positive 1, which is equal to 3, and that is exactly the 3 we are looking for, that is here. Therefore, the two factors are positive 2 and positive 1. So we bring in this positive 2 inside the first bracket and bring in the positive 1 inside the second bracket. So we have succeeded in factorizing this quadratic expression. Then we can now go ahead to equate it to 0 to enable us solve the quadratic equations. So we go ahead. Since product of two numbers or expression is equal to 0, it means either x plus 2 is equal to 0 or x plus 1 is equal to 0. We can now solve these linear equations to get the values of x. So solving this, taking this positive 2 to the right hand side, x is equal to negative 2, and taking this positive 1 to the right hand side, x is equal to negative 1. So these are the values of x which satisfy the solution of this equation in problem 1a. So we go to problem 1b. Also, we should look at it that the coefficient of x squared is still 1. Therefore, our concern is on the constant term. So we get our brackets opened. Then we are looking for two factors of 12. Let's point it out here that the factor of number we are looking for is positive, but the sum we are looking for is negative. That is to say, the two factors we are going to be having must both be negative factors. So that that is to say, if we are looking for two factors, when we add them we still give us a negative 7. So we cannot go for 1 and 12. We can't go for 2 and 6. The sum will not give us negative 7. We can go for 3 and 4. So if you are going for 3 and 4, 3 plus 4 will give us 7. But what we have here is negative 7. So we attach negative to both 3 and 4. So that we now have it as negative 4 and negative 3. So that the sum now will be negative 4 plus negative 3, which gives negative 7. So these are the factors we are looking for. So we bring in the factors into the two brackets, so that we now have it as minus 4 4x minus 3 is equal to 0. So we have x minus 4 equal to 0, or x minus 3 equals 0. So from here, solving this, we have x is equal to 4 or x is equal to 3. So these are the values of x which satisfy the equation x squared minus 7x plus 12 equals 0. So we go to problem C. For problem C, I have m squared plus 5m minus 14 is equal to 0. In the same vein, this m squared here has a coefficient of 1. So we just open the bracket with m. Then the constant term here is negative 14. So we are looking for two factors of negative 14 whose sum is 5. Since we are looking for two factors of a negative number and the sum we are looking for is positive, it means one of the factors must be positive. That is, the larger factor must be positive, so that in that case, when you subtract them, you get positive 5. So we can go for 14 and 1. We can quickly go for 2 and 7. Yeah, 2 and 7, where 7 will be positive and 2 will be negative. So that positive 7 times negative 2 will give you negative 14, and 7 minus 2 gives so we have the factors as positive 7 and negative 2, and their sum now will be positive 7 plus negative 2, which will give us 5. So this is the 5 we have here. So we now bring in the factors. So we have a plus 7 in the first bracket, minus 2 in the second bracket equals 0. So we know x plus 7 is equal to 0, or x minus 2 equals 0. So we now solve the two linear equations. The first one, m is equal to negative 7 or m is equal to 2. These are the values of m which satisfy the equations in 1C. So we go to problem 1D. For problem 1D, I have y squared minus 7y minus 8 is equal to 0. In this case, the coefficient of y squared again is 1. So I bring in my brackets, y in the bracket and y in the other bracket. So I'm going to fill in the spaces with the factors obtained from here. The constant term here is negative 8, so we are looking for factors of negative 8, and the sum we are looking for is negative 7. Again, one of the factors again will be positive and the other factor will be negative. Let me clear it here now that since the sum of the number we are looking for is negative, it means when we get the two factors, the larger number will be negative. So if we start immediately from 8 and 1 itself, that's to say it's going to be negative 8 and 1. So the two factors are negative 8 and positive 1, so that their sum will be negative 8 plus 1 will give us a negative 7. So this is the negative 7 we are looking for here. Therefore, the two factors are negative 8 and positive 1. So we bring in the negative 8 in the first bracket and positive 1 in the second bracket equals 0. So again we say y minus 8 is equal to 0, or y plus 1 is equal to 0. Solving this, y is equal to 8 or y is equal to negative 1. These are the values of y which give the solution of the quadratic equations in problem 1D. And that is the end of solution to problem 1. We go to problem 2. For problem 2, find the roots of these quadratic equations. For your information, to find the roots of a particular quadratic equation is as good as find the values of the variable represented in the equation. So we start the solution for problem 2a. This is another case. The first term, which is 2a squared, the middle term, which is 5a plus 2 is equal to 0. This is still arranged in standard form. The standard form arrangement of quadratic equation is the degree 2 comes first, followed by degree 1, and the constant come third, if you are arranging it in descending order. If you are arranging it in ascending order, the constant comes first. The middle term will be the coefficient of the variable with degree 1, and degree 2 comes third. And that one will be ascending order of arrangement. Now, since the coefficient of a squared here, that is degree 2, is not 1, we have it as 2. We are going to have 2a in our bracket and 2a in the other bracket. Now, the factors of the number we are going to look for is not just the constant term here, because the coefficient of a squared here is not 1. If the coefficient of a squared is 1, like in problem 1, we would have just picked the constant. But now that the coefficient of a squared is not 1, so we pick the coefficient there, which is 2, multiply it by this constant, that will give us a 4. Then we now look for factors of 4, whose sum is positive 5. And if you go by picking the number itself and 1, we are immediately there. So the two factors are 4 and 1. The sum is positive 4 plus positive 1, which gives 5. So we now bring in the 4 here. So we now have it as positive 4, then positive 1 equals 0. You can see now 2 can divide this. 2 is a factor here. 2 can divide 2a, and it can divide 4. So that in solving this problem, we are not going to use 2a plus 4 again. We just use the 2 to divide them. We now have a plus 2 is equal to 0 after dividing by 2, or 2a plus 1 is equal to 0. You can now see that if you multiply a times 2a, you get your 2a squared. So now we solve this. A is equal to negative 2, or a is equal to negative half. Taking this to the other side, negative 1 dividing by 2, we have negative half. So that is the end of solution to problem 2a. We go to problem 2b. For problem 2b, I have 5y squared minus 11y plus 2 is equal to 0. Again, the coefficient of y squared is not 1. So we are bringing into our bracket 5y, 5y. Then we are not looking for the constant term alone for our factors. We are looking for the coefficient of y squared, which is 5, multiplied by 2, which is the constant, will give us a 10. We now look for two factors of a 10, and the sum we are looking for is negative 11. We are going to have our both factors negative. Yeah, since the factor of the number we are looking for is positive and the sum we are looking for is negative, so the two factors are going to be negative. So if we start immediately from 10 and 1, and we are there, so we attach negative to both of them, so we have it as negative 10 and negative 1, so that the sum will be negative 11. Negative 10 plus negative 1 gives negative 11, which is the negative 11 we are looking for here. Now we bring in the negative 10, negative 1. Can you immediately see that 5 is a factor here? 5 is a factor, so that is how it is always going to be. So equal to 0 now, we can now solve. In the solution, dividing this by 5, I can quickly have y minus 2 equals 0. After dividing by 5, this y is left. 10 divided by 5, 2. We are there. Or 5y minus 1 equals 0. Solving this, y is equal to 2, or y is equal to 1 over 5. So these are the values of y which satisfy the equations in problem 2b. So we go to problem 2c. For problem 2c, I have 7p squared plus 26p minus 8 is equal to 0. Again, we are looking at 7p in our brackets. So we have 7p in the first bracket, 7p in the second bracket. The constant term here is negative 8, and the coefficient of p squared here is 7. So 7 times negative 8 will give us negative 56. So we are looking for two factors of negative 56 whose sum will give us a positive 26. Oh, that's to say, since the factors of the number we are looking for is negative, we are going to have one positive, one negative, and the sum we are looking for is positive. Therefore, the larger number will be positive. So get it there. We can't go with 1 and 56. Let's try 2 and 28. Yeah, because 28 minus 2 will give us 26. Wow, the factors are 28 and negative 2, because their sum will be plus 28 plus negative 2 will give us positive 26. Yeah, we are there. So we bring in the positive 28 here and negative 2 here equals 0. Can you see that 7 divides this? Yeah, 7 is a factor. We will be left with p plus 4. P plus 4 is equal to 0, or 7p minus 2 is equal to 0. So we are there. We can now solve. Here p is equal to negative 4, or p is equal to 2 over 7. So these are the values of p which satisfy the equations in problem 2c. So we go to problem 2d. For problem 2d, the coefficient of x squared here is 8, and the constant term is negative 5. So we have our bracket 8x and the second bracket 8x. And now we are looking at 8 times negative 5. So we are looking for two factors of negative 40. Since 8 times negative 5 is negative 40. Now the sum we are looking for is negative 6. And we should know that the two factors we are looking for, one must be positive and one must be negative. Only that the larger number will take the negative sign. Yes. We can't go with 1 and 40. No. We can't go with 2 and 20. No. No. 10 and 4. 10 and 4 first will give us 40. Which one will get the negative? Oh, the 10 will get negative. So the factors are positive 4 and negative 10. And the sum will be positive 4 plus negative 10 gives negative 6. This is the negative 6 here. So our factors now are 4 and negative 10. So we'll bring in the positive 4 here in the first bracket, bring in the negative 10 in the second bracket. This is equal to 0. 4 divides this. We'll be left with 2x plus 1. which means 2x plus 1 is equal to 0. To divide this so that it will give us 4x minus 5. 4x minus 5, okay? So that will give us 4x minus 5 is equal to 0. So actually the factors are 2x plus 1 and 4x minus 5. So from here we can now solve these equations. 2x plus 1 is equal to 0. If you take this to the other side, it will be negative 1 dividing by 2 will give us x is equal to negative half. Here, this is going to be positive 5 over 4. X is 5 over 4. And we cannot leave our answer as improper fraction. Changing it to mixed fraction, we have it as 1 whole number 1 over 4. These are the values of x which satisfy the equation in problem 2D. And that is the end of the solution to problem 2. We go to problem 3. For problem 3, factorize 25x squared minus 98x plus 69. Hence, solve the equation 25x squared minus 98x plus 69 is equal to 0. Wow. We have very large numbers. And to get their factors will be cumbersome. If we are to multiply this, it will be too large. Why can't we split 25 into the product of its factors and 69 into the product of its factors? Yeah, before we go, we get our brackets. Since the coefficient of x squared here is 25 and the constant term is 69, so in our bracket we have 25x into 25x. Now we split 25 into the product of its factors. So 25 is 5 times 5. 69, we have it as 3 times 23. 69 is 3 times 23. Now all these now are prime factors. That's very good. Now the factors of the numbers we are looking for are positive. 25 is positive, 69 is positive. So which means the two factors we are looking for are negative. And when we add them, they will give us negative 98. Now 25, because 5 times 5 is 25 times 3 will give us 75. 75 will give us 98. Wow, we are there. So the factors are negative 75 and negative 23. Yes, because negative 75 plus negative 23 will give us negative 98. Wow, we got the factors. So we bring in the first factor, minus 75 minus 23. Now remember, 25 divides this. So divide this by 25 will give us x minus 3. So our factor, the first factor is x minus 3. And the second factor will still be maintained. So we have factorized the expression 25x squared minus 98x plus 69. So we go to the second part of the problem. We have to solve the equation 25x squared minus 98x plus 69. So we have the equation here, and the left hand side is the same thing as the expression given to us. So which has factors x minus 3 and 25x minus 23 equal to 0. And from here, x minus 3 is equal to 0, or 25x minus 23 is equal to 0. Solving this, x is equal to 3, or x is equal to 23 over 25. So we've solved the equations in the second part of the problem. And that is the end of solution to problem 3. And we are ending this tutorial here, and I hope you enjoyed it. If you enjoyed this tutorial, please subscribe to our YouTube channel. Check the description section of this video on our YouTube channel to get more videos on quadratic equations, the completing the square method, the formula method, and the graphical method, plus other miscellaneous problem on quadratic equation. Until we come your way again, goodbye.